Hello, geometry. Oh, goodness. How are you? I hope you're well. I have a little warm up for you to start this video. We're going to be talking about an algebraic thing this time. We're stepping away from geometry for just a minute because we're going to use something that you might not have seen yet to make your geometry calculations a little more simple. So first of all, why don't you pause this video and simplify these radicals. Go. All right. So what you probably did was remembered that when you take with number 1, that when you take the square root of 4, you get 2. That's something that a lot of people just kind of know, but you could also plug that into a calculator and you would get 2. So the square root of 4 is 2. These values are exactly the same. One way of expressing the value 2 is this, and another way is that. They are the same. Same thing with number 2. The square root of 25 can be expressed in another way, and that's essentially simplifying that radical. We can take square root of 25 and plug it into a calculator, and we will get 5. And so these two symbols, this 5 and that square root of 25, are exactly the same value, and they're the same way of saying the same thing. Now, in number 3, I don't know what the square root of 504 is off the top of my head, and so I'm going to plug that into a calculator. 504 square root, 504 square root. I have to put, in my calculator, I have to put the number in and then press the square root symbol. Your calculator might be different. And mine says that the square root of 504 is 22.44994432. So this is where the first question ends up coming up with a lot of people. What do I write? We know, you already know that you're going to write this part. But how many places are you going to write after that decimal point? Well, I usually default to 2 places. But no matter what you do, you're still not putting the exact answer. You're not putting the exact same value. The square root of 504 is not exactly 22.45. It's not even exactly 22.44994432 because your calculator has already rounded it. In fact, this is a decimal approximation of the square root of 504. It's not the exact answer. Now, it's not wrong, it's just not exact. In number 1, the square root of 4 is 2. It's just this whole number. It's the exact right answer. In number 2, the square root of 25 is 5. That's exactly the same as number 1. It just has this nice whole number. But as soon as you get a complicated square root, like the square root of 504, you start getting these decimals. And if you're asked for the exact answer, you're not getting that exact answer. The other thing that happens when we're simplifying square roots is that it disguises what we're trying to do for our geometry. So today we're going to learn how to deal with every video, you guys. I get my alarm to go off. Anyway, what we're going to do in this video is learn how to deal with radical expressions, simplifying them in a way that is going to make our geometry a lot easier. So here we go. Right now might be a real good time to get your notebook updated, write yourself some questions, write yourself a summary, go ahead and get a new note page started at this point of the year. Yeah, you know what to do. Okay, so the essential question today, how can you simplify a radical expression? And the topic is simplifying radicals. The idea here today is that I'm going to show you a way to simplify numbers into another way of expressing that number so that you can take some shortcuts when it comes to right triangles. This has all come together out in the wash. So when you work with the Pythagorean theorem, you often have to deal with radical expressions. And the reason why is because the Pythagorean theorem has squares in it. And whenever you're dealing with squares, you're probably going to have to end up taking the square root of something. And when you do that, most people just use a calculator to find some decimal approximation, like what we did in the warm-up when we found that the square root of 504 was 22.4, what did I say, 5? But these are not a really great way to deal with geometry. They actually make your life a little bit harder, and you're going to have to trust me on this. What we're going to do today is practice working with radical expressions and simplification of radical expressions so you can have a happier life. You'll actually be applying this to pretty specific right triangles, and it's going to make your work with these right triangles so much easier. And oh, by the way, this topic that we're about to talk about today is the number one topic that people come back to me when they go to Algebra 2, which is the class after geometry, and they're like, oh my gosh, Miss Waite, thank you so much for teaching us about that, because we're having to use it in Algebra 2, and it's just making my life so much easier. So trust me on this one. You're gonna wanna learn it. All right, but first we need to understand some rules. Now, hopefully you've been exposed to these rules before. If not, please don't get too crazy. It's not that big a deal, but we just have to understand that math has some truths. And so one of the things that you should know is if you take the square root of one number and you multiply it by the square root of another number, that's the same as the square root of both of those numbers multiplied. So that's rule number one, first of all. And then rule number two is if you take the square root of a number times the square root of the same number, you get that number back. That's important to know. Another thing that we've already talked about in this class is if you take the square root of some number and you square it, you get that number back. Then another one is that if you take a number times the square root of a number and then multiply that by another number times the square root of still another number, that's the same as multiplying the two numbers that are outside the radical expression and then the two numbers that are inside the radical expression. In other words, you can reorder the multiplication, which you've always been able to do that. And then also, if you take the square root of a fraction, that's the same thing as taking the square root of the top and the square root of the bottom. Now, these are going to be coming in handy, but you don't have to have them memorized or anything. They're just pretty great rules to know. So, for example, if we want to take a square root of a number and multiply it times the square root of another number, this is the rule that we're going to use from the previous page. And it turns out that we can take this thing that looks like this, and we can condense it down into something that looks like that. So if we have the square root of 3 times the square root of 2, what we really have is the square root of 3 times 2, according to our little rule. And then we can simplify that, square root of 6, and then this ends up being the answer. So this is one way of simplifying square root expressions. Here's another example. If we wanted to square the square root of 5, we use this rule right here. And when you square the square root of anything, you just get that thing back. And that is very handy. And you've been doing that with your Pythagorean theorem problems. The square root of x squared is always x. The square root of c squared is c. It's just the thing underneath that square root symbol. So then we might start to get freaked out if we see something like this, but 4 times the square root of 3 and 2 times the square root of 5 are just numbers. We can just multiply them, and we can use this rule right here to help us break it into pieces that make a little bit more sense. So if we have 4 times the square root of 3 and 2 times the square root of 5, that's the same thing as 4 times 2 times the square root of 3 times 5. We can just pull those pieces together, the numbers that are outside the radical expression and the numbers that are inside the radical expression. They stay together and can be separated. And now we know that we have 4 times 2, which is 8 here, times the square root of 3 times 5, which is 15 there. And that is your answer. Now, 8 times the square root of 15 might be a number that kind of freaks you out right now. But we've had these conversations before where there was a time when this number freaked you out. But then you got experience with it, and then this number freaked you out, something that looked like that. But then you got some experience, and this right here may still freak you out, but you at least know that it's a number. 8 times the square root of 15 is a number. That's all it is. It's just a different way of expressing a number than you have experience with. But trust me, you're going to see a bunch of numbers that look like this coming up, and you're going to be like, oh my gosh, this is so cool, because it makes it so much easier than when you're working with decimals. All right, so here's another one. 3 times the square root of 6 times 2 times the square root of 3. We're just going to pull the 3 and the 2 together and the 6 and the 3 under the radical symbol. So we have 3 times 2 times the square root of 6 times 3. And then we just do that multiplication. 3 times 2 is 6 times the square root of 6 times 3, which is 18. And there you go. You can just pull those pieces together and essentially simplify this into a nice little number, 6 times the square root of 18. And there's no need to use a calculator. That's the thing that's so nice about this, is that these are great, just exactly the way they are. No need to pick up a calculator now and figure out what the square root of 18 is and then multiply that by 6 and get some decimal approximation of your answer. Expressing yourself as 6 times the square root of 18 is beautiful. It's exact. It doesn't require a ton of extra work. It's great. All right. So put a pause for just a second in your mind on this radical expression thing. The next thing we need to talk about is prime numbers, because we're going to be using prime numbers to simplify radical expressions here in just a bit. Prime numbers are super helpful in this process. If you'll remember way back when, prime numbers are numbers divisible by themselves and 1. So there's a lot of prime numbers. In fact, there's an infinity of prime numbers. And by the way, they're a little more complicated than just divisible by themselves as 1. There's other more mathy definitions that are better, but for our purposes, that's all we really need to know. And the other thing you really need to know is that the first 6 primes are 2, 3, 5, 7, 11, and 13. It is very likely that those are the only prime numbers that you're going to need to worry about as we go through this process. So just jot those down, 2, 3, 5, 7, 11, and 13, and I'll tell you why they're important here in just a bit. All right. So it's time to simplify radical expressions. We're going to take everything about those rules that we talked about before and the idea that we can use prime numbers and pull it together to simplify radical expressions so that we can, 1, get the exact answer to a problem, and 2, understand right triangles better. Okay? So here I have the square root of 40. Now, if you pick up a calculator and you just pop in the square root of 40, what you're going to get is 6.324555532, which is not the exact answer. It's not. Instead, what I want is to break this down, is to break this square root of 40 down so that I have the exact answer. So the first thing we're going to do is we're going to prime factor 40. Do you remember factor trees back in the day? I'm going to do this over here. Now, 40, if you had to think about, so factor trees are ways of coming up with lists of numbers that you would multiply to get the number up above. In other words, 40 is like 2 times 20, right? And then from here, you might say that 20 is 2 times 10, correct? And then 10 is like 2 times 5, yes? And from there, you'd have trouble kind of breaking things down. You could say that 2 is 2 times 1 and 2 is 2 times 1, but that's not very helpful. What you want to do is you want to break a number down. Oh, What happened? Where did my... Sorry, I'm having a technical issue. Okay, there we go. What you want to do is create a factor tree that results in a string of prime numbers, which is why we call it prime factoring. And remember, our first 5 primes are 2, 3, 5, 7, 11, and 13, our first 6 primes. And notice that we have a 2, a 2, a 2, and a 5. We have prime factored these numbers because we found the prime numbers that have to be multiplied to get that bigger number that's under the radical. In other words, 40 equals 2 times 2 times 2 times 5. And you can plug it into a calculator if you don't believe me, but 2 times 2 is 4, 4 times 2 is 8, and 8 times 5 is 40. So what we've done is we've broken 40 down into its unique prime factorization, the set of prime numbers that you have to multiply to get that individual number. Now, the interesting thing is that if you want to know the square root of 40, that's the same thing as knowing the square root of these. And that becomes significant because we want to take the next step. And I'm going to call this jailbreak. And here's what I mean. Hopefully you've never been to jail. But if you have, or you know someone who has, or you've ever heard about being in jail, the thing is everybody wants to get out. Everybody wants to escape. And in order to escape jail, you need a partner. But the trouble is that someone always dies. I know, it's sad, but it's true. That's the same with radical expressions. If you think about breaking the numbers out of the radical as breaking somebody out of jail, you can remember this technique. So here it is really. We've got these numbers that are underneath this radical symbol, the 2, the 2, the 2, and the 5, and they are in jail. The jail is that radical symbol, and they want to bust out because everybody wants to bust out of jail. But what you need is a partner. So this 2 here and this 2 here could be partnered. They can be partnered up, and they're going to attempt to bust out of jail. Now this 2 here doesn't have a partner, and that 5 doesn't have a partner, so they're not going to get to break out. Because in order to break out of jail, you need a partner, but here's the problem. Someone always dies. And so one of these partnerships has to go away, because someone always dies. But then when they do, when that happens, this other guy does get out. And what we have now is a 2 on the outside. That other 2 died, and then we have another 2, the 2 that didn't get to break out, and the 5 that didn't get to break out. So we have simplified by doing what I like to call jailbreak. And then the last thing to do is to multiply to simplify. So notice that we have this 2 on the outside, that stays out. And then 2 times 5 inside this radical, which is 10, and that is done. The square root of 40 and the 2 times the square root of 10 have the exact same value. And if you plug those into a calculator, you're going to get the exact same decimal expression. It's just that 2 times the square root of 10 is the exact simplification of square root of 40. It's not an approximation of the answer, it's the exact simplification. All right, that's a lot to take in, so let's do it again. The bottom line here is that you're going to be prime factoring the number that's under the radical. Then you're going to be partnering as many numbers as you can up, and then you're going to be killing one of them off, and then everybody who has a partner who died goes to the outside, and then you multiply to simplify. All right, here we go. So we got 24, and we want to simplify this radical expression. So the first step is to prime factor the number. So I'm going to take 24, and I'm going to start to break it down. Now, I like to just start dividing by 2. That's the smallest prime number. 2, 3, 5, 7, 11, and 13 are the prime numbers that we're usually going to use for this process. I like to start with the first one, 2, and see if it goes into the number that I'm trying to prime factor. And it turns out 2 does go into 24 12 times. 2 times 12 is 24. And then I'm going to tell myself, well, okay, since this 2 is prime, I'm going to circle it. I like to circle my prime so I know I don't have to break those down any further. But this 12 is divisible by 2. 2 times 6 is 12. And so there's another prime number. And then 2 times 3 is 6. Here's a prime number. Oh, and there's another prime number. And once I've gotten to the point where I've got all prime numbers, I'm done prime factoring. So what turns out is that 24 equals 2 times 2 times 2 times 3. And if I want the square root of 24, I take the square root of that. That takes care of the prime factoring. Now, in order to jailbreak this, I'm going to have to partner up some of these numbers. Notice that there are 3 2s and 1 3. I can partner up these 2 2s, and then the third 2 doesn't have a partner, so has to stay inside. The 3 never had a partner in the first place, has to stay inside. So we've got this partner up thing done. And then we have to kill someone off, because unfortunately, when you break out of jail and you're in a partnership, someone always dies. And so one of these guys has to go. That one right there will work just fine, but that means that this one gets to get out. So we've killed someone off. So that means that the square root of 24 is the same as the 2 that's on the outside times the square root of the 2 times 3 that's left inside. And now we're going to multiply to simplify. We have 2 times the square root of 2 times 3, which is 6, and that's done. So in order to take that square root of 24 and break it down to its simplest form, we prime factor, we partner up, we kill someone off, we multiply to simplify, and we get the simplified version of square root of 24, which is 2 times the square root of 6. If you plug both of those numbers into a calculator, you're going to get the same decimal approximation because they have the exact same value. All right, let's do it again a couple times. All right, square root of 504. Now this one's a little bit trickier, so I'm going to start with my factor tree. Whoops, that's not a 4. You start again. Let's take 504 and let's start breaking it down. Now I'm going to start with that first prime number, 2. And for this, it's okay to grab a calculator. I'm going to see if 2 can go into 504. 504 divided by 2. Oops, I did not put that in right. 504 divided by 2 is 252. So I have 2 and 252. All right, there's one prime number. Now I know that 252 is divisible by 2, so I'll just put divide by 2, and I get 126. 2 times 126. Now when you're playing around with these, if you punch in a prime number and you get a decimal, you know that this number is not evenly divisible by that prime, and so you got to move on to a different prime. But here's a 2, and then 126, is it divisible by 2? Divide by 2. Yeah, I got a whole number, 63, so 2 times 63. Now, let's see what happens when I try to divide 63 by 2. Divide by 2. Well, see, I got a decimal. So, since we have 2, 3, 5, 7, 11, and 13, we've taken care of all the 2's. Now we're going to see if we can divide by 3. So 63 divided by 3 is 21. Fantastic. So I got a 3 times 21. Now 3 is prime, so I'm going to circle it. Let's stick with the 3's. Can I divide 21 by 3? 21 divided by 3, yep, is 7. Here we go. I used a 3. Oh, and I got another prime number, a 7, so I'm done. And that means that the square root of 504 is the same as the square root of 2. Let's see, there's 1, 2, 3 2's. Excuse me, 2 3's and a 7. 1, 2, 3 2's, 2 3's, and 1 7. Yep, okay. So we've taken care of prime factoring. Now we're going to partner up. So I've got 2 2's that can be together. I've got another 2 that doesn't have a partner. Oh, but I have 2 3's that can be together and a 7 that doesn't have a partner. So I've taken care of the partnering. Now I'm going to kill someone off, but you only kill off one of the partners. And so killed off a 3, killed off a 2. Now this 2 gets to come out, and so does that 3. And so what we have is 2 times 3 on the outside now. And then the only ones left are the other 2 that didn't have a partner and the 7 that didn't have the partner. And so we killed someone off. And now we're going to multiply to simplify. 2 times 3 is 6. And 2 times 7 is 14. And that is done. All right, let's take a look at 792. Make a little room here. Start up here, 792. Let's see, can I divide it by 2? 792 divided by 2 is 396. So 2 and 396. 2 is a prime. I'm going to try to divide that by 2 again. Divide by 2. Yep, I get 198. 2 and 198. I'm going to see if I can divide 198 by 2. Divided by 2 is 99. 2 and 99. And then let's see, 99 divided by 2 is, oh, it's a decimal. So I'm going to go to the 3, the next prime. 99 divided by 3 is 33. 3 and 33. Keep dividing by 3. Divide by 3. Oh, I get 11. 3 and 11. And since 11 shows up on our prime list, we know we're done. Separate these out. I'm starting to get confusing. So the square root, or rather 792, is the same as 1, 2, 3 2's. 1, 2, 3, gosh, I keep doing that, 2's. 2 3's, and an 11. And the square root of 792 is the same as the square root of those guys. So we took care of prime factoring. Now we're going to partner up. I can partner up these 2's. There's a third 2 that doesn't get a partner, and there's 2 3's again, very much like the last problem, and then that 11 doesn't have a partner. So that part's done. Kill someone off, 1 out of each partnership, and then that 2 gets out, and the 3 gets out, and who's left inside is the 2 and the 11. And then we multiply to simplify. 2 times 3 is 6, and 2 times 11 is 22, and that is done. It's the same process over and over again, taking that big radical expression and condensing it down, simplifying it to its most simplest and exact form. All right, shall we do more? I just want you to see it a bunch of times because I don't want you to be confused. So let's take the square root of 85 and start to break it down. Let's see, 85 divided by 2 is, oh, a decimal. So we've got our primes, 2, 3, 5, 7, 11, and 13. So since 2 won't work, I'm going to move on to 3. Let's see, 85 divided by 3. Whoop, I got another decimal. So 2 didn't work, 3 didn't work. I'm going to take 5 this time. 85 divided by 5. Oh, I get a 17. Good. 85 divided by 5 is 17. Now 17 divided by 2 doesn't work. 17 divided by 3 doesn't work. Let's see, 17 divided by 5. Nope. 17 divided by 7. Nope. I'm going to continue to get decimals. Do you want to know why? Because 17 is a prime number. And so it turns out that when I split this 85 into 2, I instantly got 2 prime numbers. And that means The square root of 85 is already simplified. It's not going to get simpler than that. There's not going to be any partners to partner up. There's nobody to kill off. There's nobody to bring out. So square root of 85 is just done. If you run into a time when you go to prime factor a number and it splits into two prime numbers, that's already simplified. Let's take a look at 576. So 576, sorry, the square root of 576. Let's break down 576 using prime factoring. So 576 divided by 2, yeah, I get a whole number, 288. 2 times 288. Now let's see, 288, is that divisible by 2? Yep. 144. 2 times 144, and then I'm going to see what happens with 144. Divide it by 2. Yep, I get 72. 2 and 72. And then divide 72 by 2. I get 36. And then another 2, divide by 2. Yep, I get 18. Whoops, 2 and 18. And then divide by 2, and I get 9. And then 9 is not divisible by 2, but 3 is, and 3 times 3 is 9, and 3 is prime, and so we're finally done. So 576 equals 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6 2s. And 2 3s. All right, and the square root of 576 is the same as the square root of all of that. So we have prime factor. Now let's partner up. I've got those 2's can partner up. These 2's can partner up. These 2's can partner up. And these 3's can partner up. And so it looks to me like I can kill one off from each of these, and everybody makes it out. In other words, this 2 times that 2 times this 2 times this 3. And there is no radical symbol because everybody either got out or died. And this happens. So then we still multiply to simplify. We have 2 times 2, which is 4, 4 times 2, which is 8, and then 8 times 3, which is 24. And so it turns out that our answer is a whole number in this case. And if you take 576 and you take the square root of it, you get 24. So this is a couple of special cases that you should see. Sometimes you get answers, most of the time you're going to get answers that look like these, some number times the square root of another number. But sometimes, as in this case here, you'll find that when you break that number down into parts, it instantly divides to only prime numbers, and so there's nothing to do, it's already in simplest form. Or sometimes that thing breaks down into all partnerships, and so everybody gets out, and you end up with a whole number answer. These are all the possibilities. Hopefully that's not too confusing. Okay, here's the last thing. What if a letter gets thrown in? So in other words, what if we have something like this? Let's say 12x squared y cubed, and we want to find the square root of that. It's basically exactly the same thing, except you kind of have to do things separately. So the first thing to do is to prime factor the 12, as if it was by itself. So 12 is 2 times 6, and 6 is 2 times 3, and there's your primes, okay? Then you just want to remember what this means and what this means. X squared is just x times x. Y cubed is just y times y times y. And then you represent the 12 with your prime factorization, 2 times 2 times 3. And that's what you're going to do. You'll be taking the square root of all of that. So break down the number separately. That goes under your radical. and then break your letters up into the number of letters that this number indicates. X squared is x times x. Y cubed is y times y times y. And now follow the same set of rules. Partner guys up. So we got two 2's. The 3 has to stay by itself, but we have two x's that can be partnered, and we have two y's that can be partnered, and a y that gets left behind. So we're going to kill off one from each partnership, that one, and that one. And so it looks like we have a 2, an x, and a y that are going to come out. So 2xy times the square root of what's left, the 3, and a y. Done. And that is the simplified, quote-unquote, version. So even if they throw letters in, you can still do this. It's just a matter of expressing those kind of blown out. X squared is 2x's, y cubed is 3y's, and just partner up and break them out just like you did before. All right, you guys, so your practice today is on quizzes. It is not a quiz. It's just a homework assignment. I just wanted you to work on this skill. You're going to see how it applies to geometry next time. All right, y'all, have a great day. Bye.